Question 710. The graphs of the function f is equal to e to the x and g is equal to negative 4x plus 2 are given as shown above. The question is, what is the area of A? In order to find the area of this region right here, we actually have to split this region into two regions. That is interval from 0 to 0.2 and the interval from 0.2 to 1/2, right? So this region right here would be definite integral of this curve right here, f of x. This region right here will be definite integral of this curve, right? So let's write the area of this region. So area A is equal to definite integral from 0 to 0.2 f of x dx plus from 0.2 to 1/2. 1/2 is actually 0.5, right? G of x dx, right? So 0 to 0.2, f of x is equal to e to the x dx plus integral 0.2, 0.5, g of x, that's negative 4x plus 2 dx. So antiderivative of e to the x, that's e to the x from 0 to 0.2 plus this one right here represents the area of this region, this red region, right? Well, we can actually use the geometry. That's just the area of the triangle, right? So 1/2 times base is 0.5 minus 0.2 times height is 1.2, right? This height is 1.2, so 1.2. So that is equal to e to the 0.2 minus e to the 0 plus 1/2 times 1.2, that's 0.6, right? This is 0.3. 0.5 minus 0.2, that's 0.3, right? So that's going to be 0.3 times 0.6, that's 0.18. 0.18. So that is equal to e to the 0.2 minus e to the 0, that's 1 plus 0.18. So that is equal to e to the 0.2 negative 1 plus 0.18, that's plus 0.82. This is our answer, the area of the region A. Question 713. Let A be the region enclosed by the graphs of x is equal to y squared minus 1 and x is equal to y plus 5 as shown above. Which of the following represents the area of the shaded region? Let's say we have two different functions f and g. Let's say this is function f of x and this is function g of x, and this is our bounded region from A to B. The area of this region is definite integral from A to B. The height is the upper curve minus lower curve, right? So the height from here to here is upper curve f of x minus g of x, right? So f of x minus g of x dx. That's our area, right? Now let's say we have two different curves like this. Let's say this is x is equal to f of y, and here let's say this is another curve, x is equal to g of y, and we're trying to find this bounded region. Okay, so intersection here, let's say this is a C, let's say this is D, right? Then the area is equal to definite integral from C to D. We have to subtract the curve on the left from the curve on the right, right? Because this is our height. Our height from here to here is that f of y minus g of y, right? So the integrand must be f of y minus g of y. That's our height of the rectangle. And dy, right? That definite integral represents the area of bounded region, right? So back to this question, 713. We have two curves right here, right? We're going to have to subtract this curve, the curve on the left, from this curve, the curve on the right, right? Here, this is our height, right? And that's going to be if this is f of y, and if this is g of y, this height is equal to f of y minus g of y, right? So area of this region A is equal to integral from -2 to 3. Lower limit is y, upper limit is also y. We have to subtract the curve on the left from the curve on the right, right? F of y minus g of y. So f of y is y plus 5. So y plus 5 minus the curve on the left, y squared minus 1 dy, right? So the answer must be B, right? Question 714. Let A be the region enclosed by the graphs of f and g. Write but do not evaluate an expression involving one or more integrals that gives the area of the region A. In order to find the region enclosed by these two functions, f and g, we're going to have to find the intersections of these two functions, right? So let f of x is equal to g of x. F of x is equal to x cubed plus x squared minus x minus 1. G of x is equal to x minus 1, right? So if we solve this equation, x cubed plus x squared minus 2x is equal to 0, right? This -1 cancels out. So far so good. Now let's factor this. This is x times x squared plus x minus 2 is equal to 0. So that's x plus 2, x minus 1 is equal to 0. So our intersection is x is equal to 0, -2, and 1, right? If we graph this function f and g, we have intersections at 0, -2, here's -2, and 1, right? We have y is equal to x minus 1. That's linear. That's going to be like that. And we have cubic functions, right? So we have intersections right here, here, and here. So the cubic functions look like, probably it looks like that, right? So we have to find the area of this region and this region. So that's going to be, let's say area is A is equal to, from -2 to 0, that's upper curve minus lower curve. Upper curve is f. This is our f. This is our g, right? So f of x minus g of x dx plus integral from 0 to 1 g of x minus f of x, right? That's going to be our area. Here I have a question for you. Is it possible to know which curve is upper curve and which curve is lower curve without drawing a graph? Yes, we find our intersection first and then substitute value between 0 and -2. let's say -1. So f of -1 is equal to -1 plus 1 plus 1 minus 1, right? That is equal to 0. G of -1 is equal to -1 minus 1, that is equal to -2, right? So we know that in this interval right here, from -2 to 0, f is greater than g of -1, right? Which means f is upper curve, right? In this interval, from 0 to 1, plug in 1/2. Then we will know that g of 1/2 is greater than f of 1/2, right? So when we write the area of this region, that's going to be definite integral from -2 to 0 upper curve f of x minus g of x dx plus from 0 to 1, that's going to be from 0 to 1 upper curve g of x minus f of x. Okay? Question 719. The graphs of the function f and g are given as shown above. If A is the region enclosed by the graphs of f and g, which of the following represents the area of the shaded region? The area of the region between two curves is always definite integral upper curve minus lower curve, right? So area A is equal to definite integral from 0 to 2, right? So 0 to 2 f of x minus g of x dx. So we have 0 to 2 f of x, that's e to the x over 2, minus g of x, that's negative x plus 1 dx, right? So that's going to be equal to 0 to 2 e to the x over 2 plus x minus 1 dx. So this is equal to, what's the antiderivative of e to the x over 2? That's 2 times e to the x over 2, right? You can use substitution to find the antiderivative of this function, e to the x over 2. Plus antiderivative of x, that's x squared over 2 minus x from 0 to 2, right? So let me write over here. So that is equal to, we're going to substitute 2. So 2 e to the power of 1 plus 4 over 2 minus 2. All of this thing minus, if we substitute 0 for x, that's going to be 2 e to the 0 plus 0 minus 0. So that's going to be 2e here plus 2 minus 2, right? So that's 0. Here, that's 1, right? This is 1. So we have a 2e minus 2, right? So if we factor 2, that's going to be 2 times e minus 1. So the answer is B, right? Question 720. If B is the region enclosed by the graph of f and y is equal to e in the first quadrant, then what is the area of region B? Here we have f of x is equal to e to the x over 2, right? So value of y is equal to e when the value of x is equal to 2, right? When this value is equal to 2, this value is e, right? So we have the line y is equal to e right over here. They are intersecting at x equal 2, right? So the reason B is right over here. This is the reason B. Now we're going to have to find the area of reason B, right? So the area of region B is equal to, here, our strategy is we're going to find the area of this rectangle first and subtract the area between, not between, under this curve right here. This part right here. Okay, that's a definite integral, right? So the area of a rectangle is from here to here, that's 2. From here to here, that's e, right? So the area of rectangle is 2e minus integral area under the curve f of x from 0 to 2. F of x dx, right? So that's going to be 2e minus integral from 0 to 2. F of x is e to the x over 2 dx. So that's going to be 2e minus antiderivative of e to the x over 2. That's 2 times e to the x over 2 from 0 to 2. So 2e minus 2 times. If we substitute 2 for x, that's going to be e to the power of 1 minus substitute 0, that's e to the 0. That's 1, right? So that's going to be 2e minus 2e minus times minus, that's plus, right? Plus 2. So 2e minus 2e, it cancels out. So the answer is 2. The area of the region B is 2. Easy? Question 722. The region is separated into 2 different regions A and B by the line x is equal to b as shown in figure above. The equation of the curve is given by y is equal to 1 over 4x plus 1. If a is equal to 3b, then what is the value of b? Okay, the equation of this curve is y is equal to 1 over 4x plus 1. And since a is 3 times b, we can write the definite integral from 0 to b. This value is b, right? 1 over 4x plus 1 dx is equal to 3 times definite integral from b to 1 over 4x plus 1 dx, right? Because this definite integral represents the area of this region, and this definite integral represents the area of this region, right? Now let's solve for b. The antiderivative of 1 over 4x plus 1, that's 4 times nat log 4x plus 1, right? From 0 to b. Remember, the derivative of nat log 4x plus 1 is equal to 1 over 4x plus 1 times chain rule, the derivative of 4x plus 1, right? Which is equal to 4. So we must have 1 over 4 here, so that this becomes, the derivative of this function becomes just 1 over 4x plus 1, right? Which means the antiderivative of this function is equal to 1 over 4 times the nat log 4x plus 1, right? So this is equal to 3 times 4 times nat log 4x plus 1 from b to 1, right? So let's eliminate 4. Okay, so that's going to be nat log 4b plus 1. Since b is positive, this expression is positive, right? So we don't have to write absolute value anymore because this is positive. Minus nat log 1, right? If we substitute 0 for x, that's nat log 1 is equal to 3 times nat log. If we substitute 1 here, that's 5 minus nat log 4b plus 1. So far so good? Okay, nat log 1 is equal to 0, right? So let's right over here, natural log 4b plus 1 is equal to 3 natural log 5 minus 3 natural log 4b plus 1. So if we add 3 natural log 4b plus 1 inside, that's going to be 4 times natural log 4b plus 1 is equal to 3 natural log 5, right? So natural log 4b plus 1 is equal to 3 over 4. 3 over 4 natural log 5, right? Or we can write that's natural log 5 to the power of 3 over 4, right? So 4b plus 1 must be equal to 5 to the power of 3 over 4. Okay, so 4b plus 1 is equal to 5 to the power of 3 over 4. Okay, so what is b? Let's write right over here. We have a 4b plus 1 is equal to 5 to the 3 over 4. So 4b is equal to 5 to the 3 over 4 minus 1. So b is equal to 5 to the 3 over 4 minus 1 over 4, right? This is our b.